Okay, can you tell me what kind these are? Exponential, because they have a x in the exponent. All right, and this is a simple kind. These are all three related, and they're just this kind of a graph, except what happens as each number gets bigger and bigger in the base there. It's steeper and steeper. Doesn't it always go through the 0, 1? Yes, it does. These, they start out, there's some morphs on the original ones. They're just moved a little bit. And this is like the parent one, except moved which way? One to the left. Would that mean I'm no longer at 1 here? Yes, it would mean I'm no longer at 1. If this whole thing gets moved 1 to the left, then I grab it, and I'm going to slide it 1 to the left, and it looks something like that. It's no longer touching its exact right spot anymore. Okay, so it doesn't necessarily always keep that y-intercept if you change it. That would move the whole graph where? Up 1. What would this do to the whole graph? Up 3. What would the 3 of that do? Stretch it 3 times taller, and what would this negative do? Flip it which way? Up, down. Okay, so all of a sudden it's going to be going down instead of going up. All right, so next thing we talk about is tougher exponent situations. Like this kind, you know what the classic mistake is? Kids will write 8x to the 6th, and they're close, but what should it be? 64, because this has to be squared also. All right. This one, the common mistake is that people just get stuck. They don't know what to do with the 7 and the 2. They know that this should be x to the 7th, but they don't know what to do with the 7 and the 2. Well, basically, they just get multiplied because this is a big multiply problem, so it should be 14x to the 7th. Okay, this one is confusing because there's so many negatives running around. And I would suggest that you'd start by just putting each thing to this power. Negative 2 to the negative 2. Well, first of all, that means negative 2 to the 2nd, which is what? 4. And then the negative does what to that? It makes it 1/4. And now I'm going to take my x to the negative 5 to the negative 2, and that makes x to the 10th. And that's on top. So I could put it over 1 if you wanted me to, and then I could put x to the 10th over 4. All right. This one, do you know what the third root of 64 is? 4, very good. And then this, a lot of people get bound up going, I don't know what the third root of x to the 9th is. Don't do it that way. Just that times that. What's that make? So it's just 4x to the 3rd. All right, and this one, 125 to the 2/3, I better break it in parts. 125x to the 1/3 to the 2nd. You remember that? Breaking it up like that? So what's 125 to the 1/3? 5. And x to the 1/3 is just x to the 1/3. So it's 5x to the 1/3 to the 2nd. And that's going to be... Did you get what I just did there? I did it right so far. I just did x to the 1/3 is x to the 1/3. And now I know 5 squared is 25. X to the 1/3 to the 2nd is x to the 2/3. The final answer is 25x to the 2/3. All right, moving on. This is a really cool website. I showed it to you first semester. I just want to remind you about it. Wolfram Alpha. It's kind of, it's different than like Google in a way, because Google, if I type in like polar bear, it doesn't have any idea what I want to know about polar bears. So it just pulls up anything that's got a lot of stuff about polar bears. Okay. Well, what Wolfram Alpha does is it's kind of like a math version of Google, except if I type in 25, 30, 35, and 40 on my Wolfram Alpha screen, it will tell me all the possible things you could do with 25, 30, 35, and 40. Like it tells you how you could write it in different forms. It says if you wanted to continue it, like that little pattern, here's what would be next. 45 would be next, etc. Well, you can even type in really tough sequences into this thing, and it'll tell you what's coming next. So it can calculate those. It's got all kinds of cool things. It's got the mean, the median. It's got the standard deviation. In other words, how far is each number off of the mean. And anyway, I just think this is an awesome website, and I want to take a couple seconds to remind you, because you probably, it's a forgettable name, Wolfram Alpha, but it's a pretty awesome website. All right, moving on. Rationals. Rationals are fractions. So if I have this parent one, its basic graph looks kind of like this. Remember these? Remember that? Okay, that's a rational. If I want to know its domain, I say it's all real numbers except what? X cannot be what one thing? 0, because it can't let the denominator ever be 0. And then the vertical asymptotes come from these. And that spot is either a vertical asymptote or it's a hole. Which one is it? It's a vertical. So I say x equals 0, and there are no holes in this one because nothing canceled on the top and the bottom. There will be on the next one. Horizontals. That's bigger on bottom, bigger on top, same on both. Which one is it? What's the degree on the top? 0. What's the degree on the bottom? 1. So it's bigger on the bottom. Bigger on the bottom is y equals what? 0. Bigger on bottom is Bob, and Bob's a big 0. Okay, graphing it. I already did it. This one. I'm going to pause while you figure out the answers to that one. Okay, hopefully you said all real numbers except it can't be what thing? 2. Now remember, that's on the bottom here that we're looking. You don't look at the top to figure out your domain. We don't care if it becomes 0 on the top. We care if it becomes 0 on the bottom. All right, the vertical asymptotes are these, and the holes are also come from these. And this is one of those weird situations where once you cancel off an x minus 2, there's 2 of them on the bottom, so I'm just going to cancel this one and that. Well, all of a sudden, I have my 1 over x minus 2 left, but I canceled off a hole, so I have a hole at the same place where there should be an asymptote. And so in this situation, it's okay with me if you put that there'd be a hole at 2 and that there'd be an asymptote at 2, because they actually both happen there. But when you actually looked at the graph, the asymptote would make the lines veer away from that spot, so you'd never see a hole there. Okay, you won't be tested on one like that on the final, don't worry. Next up is the horizontal, bigger on bottom, bigger on top, same on both. What is it? Bigger on bottom, and that is y equals 0. 0 plus anything on the outside, there's nothing on the outside. And the last thing is the graph. This would be the parent graph except shifted which way? Right 2, because it's by the x. All right. Good enough. Moving on. Logs. Quick review of logs. This would be 2 to the 6th equals, and that's an easy one to do, right? Just 2 to the 6th. This one's x to the equals, and that's a little harder, but you just have to put both sides to the what? To the 1/6. And the next one is 2 to the x equals 2. And if you think about this, that's like a 2 to the 1, right? And now they have the same base, and so what's the answer? X must be 1. And you could have just looked at that and known, oh, that's a property. That whenever you have the same number here and here, the answer is 1, and it is. All right. Well, moving on, a recursive review. This is the stuff that the other major topic we need to go over here today, but it's pretty easy. I just want you to put that in your calculator. So grab your calculator, put it in sequence mode, and see if you can remember how to put this in. Here's the things you'll see on your calculator in sequence mode under the y equals screen. And I'll pause while you do that. So there's the equation for it that you put into the calculator. And now go to the table and look up what u sub 2 is. So this is like having $70,000 and getting 8% interest compounded monthly. What is u sub 2? Is that after 2 years? 2 months. After 2 months, you should have 70,000 what? That's the benefit of gaining interest. You used to have 70,000. Now you got 70,900. That's after only 2 months. And you might say, nobody ever gets 8% interest. Yeah, they do. Banks do. Banks get that kind of interest when they loan you money to buy your house, for instance. 8%, it's a little bit high maybe, but there's a lot of people paying 8% because they don't have perfect credit. So that's exactly what banks do. They make money on interest. All right, our last screen on this. If I had this, the only difference is it's got a minus 1,000 there. That should tell you, is this a loan or is it an investment? It's a loan. How much are they paying off on the loan? $1,000 a month. All right. And what are they paying for interest? What percent? 8%. Compounded how often? Monthly. And if I wanted to know after 1 year, would I look up u sub 1? Nope, I'd look up u sub 12 because after 12 months would be 1 year.